The twin deadly Venezuelan earthquakes on June 24, 2026 have created something of a geologic mystery. Not in Venezuela, mind you, but rather in the nation of Trinidad and Tobago, about 730 kilometers or 454 miles east of where the two magnitude 7 range earthquakes struck. There, a several hundred-foot-long swath of beach was seemingly uplifted by as much as 20 feet, specifically at a spot known as Galfa Point. This is quite perplexing, as an earthquake that far away shouldn't have caused such an extreme amount of ground motion. After all, this was a strike-slip earthquake sequence with largely horizontal rather than vertical motion, and the closest fault segment that did move from the two major earthquakes was more than 500 kilometers away. This apparent uplift was also not a fault rupture generated by a local earthquake or one of the aftershocks from Venezuela's twin major earthquakes. Now, I do want to note that already 2 other legitimate and reputable geologists who make content on YouTube have already weighed in on this topic, specifically Shawn Willsey and TheGeoModels. You should check out their videos, by the way, which is linked in the video description and on screen now. Like any good scientific mystery, they came to 2 different conclusions. Shawn Willsey suggested that the apparent uplift represented the toe of a rotational landslide, while the GeoModels suggested that a rising mud diapier that hasn't yet fully reached the surface uplifted the overlying rock through simple displacement. Both of these explanations have varying degrees of supporting evidence, which I have listed, and at the present both remain as plausible explanations. I can't for sure say which of these is correct, but there is one aspect that will help us determine this. You see, there were multiple reports by locals that visible hydrocarbons were visible and concentrated in multiple spots in the uplifted area. If this was mud diapirism related, these hydrocarbons were released by hydrocarbon-bearing rising water not far below the beach surface. On the other hand, if this was landslide related, these hydrocarbons could have been concentrated by natural groundwater or rainwater after the local hydrocarbon-bearing rock units in the landslide became exposed on the surface. Although either could be correct, I think a hybrid of the 2 explanations better suits the available data. Specifically, I think that stronger than average rainfall either on June 18, 2026 or June 24, 2026 caused an increased amount of rainwater to soak into the ground. This rainwater seeped into the local rock units and flowed through them, interacting with small amounts of hydrocarbons, which then propelled some of the water upwards. As this reached shallow depths, the water lubricated natural weak points in the local rock, and this overcame a natural threshold by reducing the level of friction between the rock units, causing a landslide to take place. Whether or not this was close to ever creating a new mud volcano is uncertain, but in my opinion, elements of both hypotheses clearly took place. To add on, here is some information about the local geology. This segment of southwestern Trinidad and Tobago is largely composed of Pleistocene and Holocene alluvium. However, other rock units are also present, such as the hydrocarbon-bearing 11.5 million to 5.5 million year old Lower Cruse Formation, whose boundary is somewhat marked by the type of local vegetation. It seems that only a portion of this broader sedimentary rock unit segment experienced uplift. Its northern boundary denotes a rock unit contact with the Upper Cruse Formation, while its southern extent is denoted by the modern shoreline segment that forms the fairly straight line, which seems to be the top of an anticline fold. Since underneath the top of anticlines can serve as a natural point for hydrocarbons to pool, it would make sense that some of this could occasionally migrate upwards through gaps in the rock, creating mud volcanoes and occasionally surface hydrocarbon seeps. I want to now note that there is a good chance the beach uplift did not occur specifically from the major Venezuelan earthquakes, as no one saw the rapid rise at the same time the seismic waves hit. June 24th merely marks when the changed beach was first noticed by locals and could have existed beforehand for several days. Is it possible that the presumed landslide or rising hydrocarbon-bearing groundwater were triggered by the two major Venezuelan earthquakes? In my opinion, absolutely not, as you need at least a minimum of an MMI4 to have the potential for triggering a landslide, yet only up to MMI 2.6 occurred in this spot. As a final note, I would like to thank this channel's patrons on Patreon and channel members on YouTube for supporting my work.